Um, so this next talk is going to be a very brief one, and that's about use of modeling as a participatory tool, a tool in teams particularly. So broadly speaking, I like to characterize the situation as one where we've been through three modeling eras. A first modeling era where modeling was largely done by consultants to whom you went, and they would do the necessary modeling to bring you the answer. This was conducted largely with generalist modelers, people who would model, one day they'd be modeling railroads, another day they'd be modeling a hospital, another day they'd be modeling competitive competition in the consumer electronics area. And the modelers had the prize tools, which were the models, which they would build on demand and provide answers to people. And this is still being done to some degree by some consultants out there. In the second era, models were built but distributed as black boxes. If any of you have worked with, for example, StatsCan with the POHEM model, this micro-simulation model, I know some of the people on the team. I know the creator of it, very creator and sort of designer, very closely, and there's been a lot of good from that model. But these models are distributed as black boxes. The people who use them don't really understand what's in it fully, typically. And as a result, they have very little flexibility in using it. They can kind of run some scenarios that are predefined. They can put in some specific assumptions for those scenarios. But the model evolution and the model use to investigate other scenarios is dependent on some developer going and developing it somewhere else. And in this case, it's with StatsCan. So you have to call up StatsCan and request that the model be modified, and some number of thousands of dollars later and some number of months later, you get an updated model. In many cases, people don't know quite what's inside of it with respect to certain assumptions. And sometimes that can lead, in situations, in my experience, it can lead to real surprise later when they discover it's actually capturing less of the dynamics than they had expected. The third era of modeling that I believe we're in now, and that I like to promote here in our work and in these boot camps, is what I term agile modeling. It can go by various names: collaborative modeling, adaptive modeling. This sort of modeling is distinguished by a couple things. It's undertaken in interdisciplinary teams. The model is actually built alongside end users. The model is relatively transparent to non-modelers. Not perfectly so, but fairly transparent. It's not just a bunch of code. It's not just a black box you have to plug numbers into. It's actually something you can look at and kind of understand broad elements of it pretty well, at the least. The end users can customize output from the model, and the end users help evolve the model assumptions. It's not done by somebody else and just given to you. It's something where you can actually contribute in evolving it, the data that's used, the assumptions associated with it. So the model here is a living document, and it evolves with the learning. And what UN presented today, and what Kurt talked about, and aspects of what Dylan has been pursuing, and what UN did here with our TB control and other components are very, very much along these lines. We've worked with folks from the SASC renal program as part of work such as this, and many of our projects increasingly fall in this area. There's still a modeler, a primary modeler, who has a lot of training in modeling, but they're building the model alongside others. So it's not just their model, it's the whole team's model. Now, I've talked with you extensively about this notion of modeling tools, and that's key to sort of much of the value that's delivered here. The model is kind of this living document, and as we learn, it evolves. We're going to come back to the modeling process and its stages later, but my observation here is from my own experience and the experience of folks like Jenny and Kurt, it's often the modeling process rather than the model created that offers the greatest value. The model is a great artifact to use. The model that UN has to be able to run scenarios in it, to see the impact of possible intervention strategies, possible new strategies to lower the wait times or to enhance throughput. Those are good things. But there's also a lot of learning that went into building towards that model. And it's this modeling process that forces groups to reflect on what they know, what they don't know, what things could they invest in learning by going and collecting new data that's most valuable. Some of the most valuable modeling of all can take place when you have the latitude to go collect new data that you decide to prioritize with the model, or undertake interventions and test the model predictions against what you actually observe when you put in place that intervention. Very, very valuable way to test out a model. It's not the only way. Those techniques we talked about earlier, cross-validation, also play a role. Aspects of model unit checking, basically testing the consistency of the model, testing its behavior under extreme conditions. Those sort of tests also raise confidence in a model. But one of the most sort of the trial by fire and the gold standard is to use the model to anticipate the outcome of a counterfactual intervention, put that intervention in place, one that's not been observed before, and see the degree to which the model predicts the consequences. That can provide some of the greatest learning with a model such as this. And this modeling process often is most valuable because it causes people to rethink their understanding of the situation, reflect on what's known and not known, and brings different perspectives and understanding to bring to bear. Working with Jenny, for example, in this modeling project with ED weights and patient flow, it's often forced the different parties to sort of listen very acutely to other people in the team who may know more with greater level of detail about different pieces of the system. So, for example, Jenny and Kelsey at HQC talking about community care options at a level more detailed than Jenny previously had been aware about them. So it really brings kind of, it's an investment in building up the team ability to sort of understand the system. It's not merely the model that comes out of it, it's often improved understanding, improved appreciation for the different pieces of the system. So this is work that we've done with a variety of partners here in Saskatchewan, and I think is a very powerful approach. One of the key components of this was mentioned by Jeff yesterday, and it's something I also mentioned in a passing. Kurt also mentioned it, and that's the fact that these models, when you create them and you show them on the computer, they themselves serve as what's sometimes called a boundary object. They serve as this common point of reference that people from many backgrounds can point to and know that they're talking about the same area of the system. It can actually enhance communication because it allows diverse stakeholders to talk about the same elements of the system in terms that each other is sure what they're talking about or clearer about what they're talking about. So having this common point of understanding allows for sort of pointing and discussing in a way that focuses the discussion, keeps it about sort of operative components of the system that are important for the model. And I would just note here that the software using very visual software is very helpful for facilitating this process. Until recently, agent-based models, for example, were often hard for folks who are not programmers to understand. They were a bunch of code that you had to look at. Now you have state charts, you have things we haven't seen them like events and action charts. You have data objects where you can understand it, and many people from diverse backgrounds can understand them. System dynamics has long served, by contrast, as a sort of leader in terms of applying the use of models as boundary objects. And this is because within system dynamics, models are often quite a bit more transparent than was traditionally the case in other modeling methodologies. So stock and flow diagrams, but particularly causal loop diagrams, can be understood by those quite quickly. So something like this, this is an early diagram created in our work, my work with Roland Dick, a nephrologist here, who's these days, for the past few decades, has worked particularly in the area of Aboriginal issues, and particularly the burden of type 2 diabetes. And we drew out a causal loop diagram within the first month or so, I think, associated with his hypothesis, one of his main hypotheses about causal pathways of relevance between gestational diabetes on the one hand and type 2 diabetes on the other. So the role played by diabetic pregnancy, both in terms of the risk to the mother, in terms of elevating risk of type 2 diabetes for her, but also in terms of outcomes for the child, for the baby that's born, the risk of macrosomia and obesity in offspring, including metabolic syndrome, and then type 2 diabetes also later in life. So within this context, these sort of diagrams can be very helpful for communicating with non-technical stakeholders. I'll tell you a story about that in just a minute. Moreover, this is a model that resulted from that, unpacking that causal diagram into a stock and flow diagram. So here we have women who are, the count of women are normal and underweight, overweight, and those with type 2 diabetes. And for women who are pregnant, we keep track of whether they're normal weight or overweight, and that influences the chance they'll develop pregnancy with gestational diabetes. Following delivery, a baby is born into the model, but the woman who gives birth also has a history of gestational diabetes that predisposes her for developing gestational diabetes once again, as well as type 2 diabetes. So we unpack that into this sort of model, and this in fact model here served as a central point of discussion in ongoing meetings with diverse clinical and public health stakeholders. So we could use a model like this interactively with those stakeholders. They could look at it, spot possible problems with it, and potentially run it themselves and examine the results from that model. Similarly, for diabetes and progression here in the Saskatoon Health Region, we have a quite articulated model. Both this and the previous model are stratified by age categories, by ethnicity, and this one by gender as well. And we have, and the other one also distinguished genders, normal weight, overweight, obese, and then successive development of diabetes from a pre-diabetic state to a diabetic state. And once again, models like this in system dynamics are fairly readily parsable. I do have a later slide where I'll perhaps talk about one particular aspect of that, and it relates to, in fact, this episode right here. So I have a colleague, Peter Hoffman, wonderful chap. He's at Washington University in St. Louis, and he has a unique background. He's an engineer by undergraduate training, like myself. He has a degree in electrical engineering. And for his graduate work, he did a PhD in social work. So he has this incredibly interesting mix of kind of engineering mathematics on the one hand and technical capacity when it comes to computational tools, with, on the other hand, an appreciation for social issues and increasingly their tie-ins with health issues. So he runs participatory modeling efforts worldwide, including in India, Mongolia, and other countries as well. He's distinguished by taking the modeling not to simply the experts in those countries, but to communities. and other teams, such as with aid workers, who have familiarity with the local context. And he ran a group model building exercise to actually build up a model, a system dynamics model, within the context of a variety of communities. And one of them is shown here, where they were constructing a system dynamics diagram concerning issues that involved livelihood, ecological degradation, and challenges faced by this village in rural India. And this modeling exercise was being undertaken within the village, within a community house in that village, and it was a group of entirely men who were participating. It was, as I understand it, it was a somewhat patriarchal society, and it was only men who were part of this group informing the modelers. And they went and they were drawing up these causal loop diagrams on the board interactively with the modelers. The modelers were talking about what the perceptions were by the village of what was going on, helping to elicit some of those connections between various factors. And they were making some good progress when something unexpected happened. So a woman from the village came looking for her husband, and she was expecting him there based on what she had been told. And she came in, and she saw this diagram that was created. It's actually this one here up on the board. And she kind of stood there, as I understand from Peter, for 10 or 15 minutes, sort of looking at what was going on, seeing them discuss this. And then she came up to the board and she said, no, actually, you've forgotten something key in this model. You know, you need to add links between this and this, and how you've represented this is not quite accurate. You know, your representation of how those imported cows ended up affecting the water situation is not quite right. You need to change it in this way. And so she started modifying the diagram. And if I'm not mistaken, this was sort of among the moments where she was pointing out the shortcomings. The point is, she was able, based on these causal loop diagrams, to quickly enough parse the essence of what was going on there to quickly be a voice in the conversation. And that's a powerful use of models, to bring together multiple voices to sort of provide an understanding of how a team or how communities see it. And the point is that these modelers, you might think of models as being very technocratic, only being built by, you know, experts with years of experience. The point is that teams, members of teams without that sort of formal training can still contribute in important ways. Now, it's only been in the past decade or so, and particularly in the past 5 years, that we've been able to extend such approaches to the agent-based modeling context. While this has long been an emphasis in system dynamics, agent-based models have traditionally been even more difficult for people to appreciate because they were created in computer code. And recently, particularly with the advent of AnyLogic in particular, we've seen a real growth in the ability of people to kind of look at a model, appreciate it, and critique it. And we call this a declarative specification of the model. It's not defined in long-winded code. It's defined graphically at a high level so that people can appreciate what is being modeled, even if they don't have all the appreciations on the how. So increasingly, we're able to take models and bring them to diverse parties and have them really understand what's being depicted and critique that, even if they weren't involved directly in building it up from scratch. Now, the key thing here is getting the programmer out of the learning loop, getting them out of the way of kind of experimenting with the model, learning from it. And traditionally, models from diverse backgrounds, but especially in the agent-based context, have been subject to this limitation that in order to see a new output, in order to investigate a new intervention, you've had to go to someone and ask them to change it and wait a week or two or sometimes longer for them to actually make that change. So if you just wanted to see a new table, you'd still have to wait for a long time. And that's really a problem when it comes to learning quickly. You want that sort of ability to interactively work with it. And one of the real advantages of having people like Dylan, like Kurt, having folks like UN work with these teams is they can undertake this work quickly. But one of the advantages of having people attend boot camps is that they can learn to interact with the model directly. And some of our clinician partners now directly will run the model. They'll actually run the model themselves. They'll inspect things. In some cases, they might disable things or enable it, perhaps add a new scenario and run the model. And that makes a world of difference for how quickly they can learn. It means they're not hostage to contingent. Their learning is not contingent on the help of another person who may be slow in getting to the action, or may not understand what their needs are. So this is an area of great investment in us. It's an area where I think is very important, and it's one of the big reasons we run our boot camps, either this one or the ones every August or the ones that run worldwide. So in any case, these sort of models that you build up, you've seen them in AnyLogic, and admittedly, the models we've shown you have been largely toy models to help build the learning. The model UN showed today is not a toy model. I'll see if this afternoon I could show another model that's not a toy model, focused on end-stage renal disease, which we've built here in the province. It's a subject of several papers, and in which is really designed to give substantive, meaningful understanding of the health and cost burden associated with end-stage renal disease here in Saskatchewan. This is another example of a model that's not a toy model. This model is from chronic wasting disease. It's that model behind the little deer running around. But suffice it to say that an important feature of AnyLogic in particular, and the main reason we teach this tool, is that you can take even a model that's quite sophisticated and put it down, and with a little bit of training, you can come to understand how it's to be interpreted, and you can actually interrogate it to understand very, very well what it's accomplishing. Maybe not all details will be clear, but you can understand most of it. So a chart like this, for example, that Kurt created as part of his individual-based modeling for the Ministry of Health project, is something that with a little bit of exposure, you could start to understand what might be associated with different elements of this, what the possible states are, what the transitions are between them. And this is far from perfect. We think it can be improved greatly, but it's a lot better than computer code. It's a lot better than just looking at code in Java or what have you to actually implement it. This is from our Saskatchewan model on diabetic end-stage renal disease. And I have to say that discrete event modeling is also fairly visual, and if you name things well, you can often have some understanding of what's being meant. This is from Kurt's model, a later model than the one we looked at earlier for the emergency department and later wards in a hospital. And you'll notice that it has similar processes to what we saw before, but at a more detailed level. So seizing a room, for example, so getting allocated a room and discharging decisions, waiting for an acute bed, taking an acute bed, etc. So high-level model created by Kurt to understand some aspects of the hospital, not a very detailed level, but at a high level. Okay, so this is a slide that Peter has used in his work, and I do want to emphasize this. We won't spend long on this, but it's an important understanding about the different uses you'll find of modeling out there. We talked earlier about stylized versus more detailed, empirically grounded models, and that's a very important distinction if you look at the diversity of models. But another one more relates to sort of what the models are, what sort of perspective the models represent. And this is based on some of Peter's work, adapted itself from some work done done by contributors to a book edited by David Lane. And in this view, models are placed in this kind of space along two dimensions. One is to what degree they reflect sort of a notion of more incremental sort of improvement versus more radical change to a system. To what degree are you talking about a dramatically different change to the medical care system here in Saskatchewan, and to what degree are you sort of tweaking around the edges of that existing system? And to what degree do they aspire to more of a sort of focused on objective views of the situation? To what degree are they capturing sort of they're more focused on how people interpret the system or their feelings about the system? Now, this may sound like an odd space to be asking about models, and there's a common understanding, for example, that in some quarters that somehow models need to fall in this quarter down here. They need to be about more incremental change and based on some sort of a very objective sort of view of the system. But you'll actually find models all over this space. There are some models that actually focus on trying to help motivate coordination among different parties within a system. So there may be a system, a broader healthcare system. I've seen this in other areas, particularly education policy, where you have different parties working at cross purposes. They're arguing, they're tussling over the provincial budget, arguing for a limited slices of limited pie, more to come to them to others. And the coordination problems here often have as much to do of changing how people think about the system, sort of the subjective side, as to the objective side of things. They have more to sort of helping the different parties come to terms with why they need each other. And I'm pleased to have been associated with a spectacular success along these lines. We were doing consulting work in the States involving educational policy for the state of Texas, and there was a constant tussle going on between the high school educators wanting to get more funds for K through 12, and those of the university system wanting to get more funds there. Our models were about the educational system as a whole, and one of the things that they helped bring out for the folks on the university side is that actually they were entangled with, they were tied together with the fate of the K through 12 system. And if they were constantly fighting to get more money for themselves at the expense of the K through 12, they were going to ultimately be hurting themselves as well. Specifically, they found that if K through 12 wasn't properly resourced, it would lead to a lot of expenses for remedial education at the university. They'd have to do a lot of makeup work for these shortcomings at the K through 12 level. And as I understand the situation, it was our model that contributed to the situation such that essentially the university system folks said, look, we need to get together with the K through 12 folks and jointly lobby for more educational money as a whole, not to fight over a limited slice of pie, but to actually grow the pie as it funds education. Because we are so tangled together in terms of our faith that if we just get your slice of pie, I'll also be in a world of hurt. So the model here did serve a purpose of changing how people thought about the situation. And in many modeling problems, that's the goal of the model. It's to kind of bring diverse teams together in one place so they can overcome their sense of suspicion and learn how to work together more effectively. And there's some fascinating work that's been done, for example, in ecological management, which brings together ranchers and environmentalists and farmers and others at the table so that they can grapple with these issues that are affecting all of them. And instead of being us versus them, it turns into a sort of where do we have shared interests and what can we do together. There's another class of problems that are also more on the subjective side that facilitate learning. How do we learn more effectively as a group? How do we help our team be in a constant learning position? And the focus here is on helping, again, shape people's understanding of the situation. By contrast, there's quite a few models that are down here in this quadrant, and we have a number that are, well, quite a large number. These are focused, they're quite technical models. They characterize things using data that's readily available, and they're focused on gaining quantitative insight into trade-off between policies, whether it's cost trade-offs or trade-offs associated with health burdens. Finally, though, there's certain versions of these models that step out of the very incremental approach and instead ask, how could we, if we could think about redoing the health context more broadly, if we could think about rethinking about how health care is delivered at a broader level, what types of designs for the healthcare system will be most effective here? And this is a very interesting and sometimes provocative ways where models can be used. It's kind of stepping back. It's a little bit more big picture. You're not tinkering around the edges. You're talking about radically redesigning a system. And I think some of Joachim's work, for example, falls very much in that category. Some of the work that Kurt Stange is doing with primary and secondary care, and some of the work that we've been thinking about in the ED weights and patient flow context also get more towards this quadrant of things. Thinking about, look, it's not about just those weights, it's about the whole system and how it works and how we can move this system to a more effective, resilient, and not merely sustainable basis. So different uses of models are a hallmark of the complex systems modeling space. And some of the work that Dylan is doing with Joachim here at the boot camp hopefully will contribute to an interesting model investment up there in the upper right. Why involve teams? I mean, why not pay a Dylan, a Winchell, a Kurt to go off into some back room, back office, close the door, and build you a model? Well, there's a lot of reasons you don't want to do that. There's a lot of examples of people who do that to this day, but there's real problems with it. And I'll frame it the other way. What's the advantage of doing it and embedded in a team, having them part of your team? Well, among other things, the team develops that understanding. It reaps the benefit of the modeling process that might otherwise be lost. The team develops a sort of rich understanding from many encounters with the model. It learns more effectively. It also can help the team critique model behavior and develop greater confidence that this model is actually solid. It can foster stakeholder cooperation by diverse parties who might otherwise be a little bit suspicious of each other's motives. By having a common model, they might be able to be motivated to realize, okay, the evidence is pretty strong here. Let's not stand in the way with this. When it comes time to implementing policy recommendations, if the people who are affected by this have been parties to contributing to the model, they have less of a sense it's being foisted on them from outside, being forced down their throats. It can aid in replanning, to sort of re-examine things as new understanding comes in, new evidence, new priorities, and aid in keeping the model updated. And finally, when it's undertaken at the community level, it engages in self-guidance. Peter talks about this dignity of risk concept, that, look, if you're going to be undertaking interventions that claim to be trying to improve the operation of a facility, of a healthcare system, or of a community, you want to give a voice to those in the community. You want to give a voice so that they feel they've been represented when it comes to the modeling process. So that's a little bit about modeling and communities. You'll see all sorts of different ways of pursuing this, from group model building at the very beginning of a modeling, brainstorming about what this model should include, to use of the model once it's built by stakeholders, interacting with it as it runs on a computer, and lots of things in between. I would just submit to you that while it's a broad spectrum, it is worth thinking about investing in that group, then that team investment in the model early on, and having that as an ongoing emphasis of the modeling. So the modeling project takes place in your organization, not done by somebody out there, or at least that there's ongoing meetings going on. This is what we have with Alberta Health Services. We're not in Alberta, but periodic, about once a month, they come and visit us, and we sit down for a day or two and go through the model together. They're running it, providing feedback, and Windchill is actually evolving the model. A little bit about the modeling process. Any questions related to that? Dylan?
Point out from the modeler's perspective, if for no other reason, it's just it makes us much more productive to be able to meet with you and to actually talk about the problems that are ongoing. It's easy for us, to build the technical stuff, but in order to get you the model that you want, in order to get it as consistent with the real world as possible, we can't just exist in a vacuum and make that stuff up. It really helps if we're talking with you. Plus, you just get better results when everybody's sitting in the same room. You have a model that is built for all stakeholders rather than just a couple of them. It's built for everyone, and everyone feels they can learn something from it, rather than just the people who are involved in building.
And often a sense of ownership over it it really helps it go much further. It's not something, again, dreamed up by Jenny or someone else. It's something which we've all contributed to. It's not being held close to the chest. It's being shared with people. It gives a much more transparent feeling to the whole enterprise. Any questions related to that, though? No? Okay. So just a little bit on that human theater side. We're going to now shift and talk about something related to this. Ooh, okay, try that again. Something closely related to this, which is the model.